Hi friends, welcome back to yet another session on operating systems. Now let's continue our discussion on the scheduling. We were on thread scheduling. Under thread scheduling, we do see what a contention scope is. The contention scope defines to what level of threads a thread competes against CPU time during scheduling. So when CPU is being scheduled, then one thread will compete with other threads, and to what level it competes is what a contention is. So basically we have two types of contentions. One is the process contention scope and the other one is system contention scope. In the process contention scope, the threads within the same process compete with each other to get the CPU time, whereas in the system contention scope, threads from all processes in the system compete with one another, and that's the difference. So here, when a thread wants to get the attention of CPU, then who all are in competition in the race. If all the threads in the same process are in the race, then we talk it as a process contention scope. But all threads in the system, if they are to be competed for any thread to get the CPU attention, then we call it system contention scope. So look at little detail about the process contention scope. Here the user level threads compete with each other, and this scheduling is done by the thread library, not the operating system. So at the user level we have thread library, and this thread library manages the scheduling of the threads under one process, and only threads in the same process compete with each other. Two threads belonging to different threads do not come in picture here. All the threads who are competing under process contention scope should belong to the same process. And here the operating system sees only the process as a single schedulable unit. Inside the process, all the threads are invisible to the operating system. So to the operating system, only the process is visible, and from inside the process, the thread library will select one of the threads and allow the operating system to see it. So only through the thread manager, thread library, the whole thing works here. Operating system has no role to play in this type of contention scope. So the example used, the green threads in the older Java systems or the custom scheduling frameworks are the one where all scheduling is done at the user level. The other one is the system contention scope, where it is used at the kernel level threads, and the operating system scheduler decides which thread to run. And here threads compete with all the threads system wide. That means there may be multiple processes wanting to compete with each other, and each process in turn may have multiple threads. So each individual thread of all the processes are now eligible for competing to get the attention of the CPU or core of the CPU and so on. And in this can allow a true multi-core concurrency, because all threads are open for competition. All the threads of all the processes are open for competition, not like the earlier one where the competition is done only within the process. So only one of the threads within a process comes out for execution, but here all threads are available. So any thread among the current situation can use any core of the processor Therefore, if we are talking about n core processor, then n threads may be attached to these n cores, and these n threads can come from any process, can be from one process. All n threads may be from one process or maybe from different processes, doesn't make any difference. That's the advantage of working with a system contention scope. So the example here is a POSIX threads on the modern Linux system, or window threads, and so on. So that's the two types of contention scopes, and that's it for now. Thank you. Please do like this video, share the video with your friends. Please do comment whatever you feel about the series, about the current video, and please do subscribe to this channel. Thank you.